All right, so sorry about that earlier. We got through the first part of Advent of Code pretty easy, but I wasn't anticipating that we would. I didn't anticipate correctly the type of data that we would need to keep track of to solve the second part. And I just got down a rabbit hole, and got lost, and I couldn't find the bug. So what I did is, like any good programmer is going to do, be comfortable with throwing one away. That's a quote by Eric S. Raymond, where if you start to go down the wrong path. Be comfortable with, not continuing down the wrong path. Take what you've done and throw it away. It's not like you're throwing away your work. You've learned something about it. You've learned something about the problem, and then if you approach it with a fresh start, you haven't wasted your time by throwing away that old code, that old work, because it gave you the experience needed to understand the problem, work through the problem, and think about what you need. And in this particular case, starting over again really helped me with this one, because I was able to, now that I had 100% knowledge of what I needed to keep track of, it was much easier. So you can see already that I've already completed the puzzle here with this number. I've done a number of things to clean up the code to make it more straightforward. I've also created a test case structure here instead of ad hoc, commenting, uncommenting things. I'm going to run all the test cases at once. And you'll see what it looks like. So now that I know what we need to keep track of, I redesigned my program to use this structure here. This is going to be treated as a Boolean, each cell is going to be a cell in the XY plane. And so we're going to keep track of several things. We're going to keep track of whether or not wire 1 has been at that cell, whether or not wire 2 has been at that cell, and these are going to be Booleans that are going to capture that idea. But in addition, I want to keep track of how many steps it takes to get to that point. And so I've got another integer here, which is not going to be treated as a Boolean. Instead, it's going to be treated as the number of steps required to get to that cell by wire 1 or wire 2 for the first time. So we're only going to set these values the first time that we set the wire 1 to true. Okay. I've also revamped this print board here, but again, it only is helpful on small examples. So if the size of the board is 50 by 50 or more, then we're not even going to print it out. But I will show you that I went ahead and changed these around. So now that we don't have a 2 by 2 integer array anymore. Instead, we're using this structure here. And I did flip these around here. Like I said, I flipped it upside down so that instead of y running from 0 to n, I'm going to run from n to 1, but it's also going to print downward, so that I don't have to do my flips here anymore. And x is just going to print left to right. So if it's that central point or central port or whatever it is, it's going to print 0. Otherwise, if neither wire is there, it's going to print a period. Otherwise, if both wires there, it'll print 3. It'll print 1. It'll print 2 for wire 1 and just wire 1 and just wire 2 respectively. Otherwise, it'll print out error. But that's not that big of a deal because it's only going to work on test case 1. Here's my general solution. Once you have a test case, and what is a test case? Well, a test case is the string that we were given by Advent of Code, the first one for the first wire and the second wire. We're also going to keep track of the minimum distance and the minimum number of steps to get to an intersection point, as well as the minimum size of the board that we need here. So for the first ones that were given as an example, we can get by with a smaller board, but as we saw for the actual example, we're going to have to go up to like 20,000 by 20,000 is the one that I found that works first. Okay. So here's just one run of one test case. We instantiate n here from that test case. We make copies of wire 1 and wire 2, those strings. And actually, I should be doing +1 here, and I was getting myself into trouble here. So already I found a bug that was not manifesting itself here, but I should have taken care of the null terminating character there. Shame on me. All right, there we go. So I make deep copies of those, but otherwise this code is going to look very similar to what we had before. I'm going to have an n by n board now, which is a two-dimensional array of cells now and structures rather than just one number. And I do have to initialize each one of these. This is going to be false. We've not seen wire 1 yet. We've not seen wire 2 yet, so those are both going to be false. And just as another flag here, I'm just going to put in the number of steps for wire 1 and wire 2 to be -1. Okay? All right. So the central port here is going to be n divided by 2, n divided by 2. So it's an n by n, but we're going to start at the center here because we might be going all over the place. We print out the board, but that's only going to work for the small first test case. Otherwise, this code is going to look very similar to what we had before. We have for the first wire, we start out at the central port. We tokenize our wire 1 string and keep a counter. This is all the same as before, in fact. I still even have my debugging code here if I want to get rid of that. There's the direction, U, D, up, down, left, right, LF. This is the distance that you have to go. Then we go into a loop for that distance. If it's up, then we're going to go up by 1. If it's down, then we're going to go down by 1 in the Y direction. X direction, positive or negative, depending on left or right. That's all the same. I also have that same error checking code here that if we go off the grid, then we print an error message, and that just means that but through trial and error, I had to go back and make the board slightly larger to accommodate until I got to something that actually worked. If this were a dynamic programming language, you would not need to do something like this because it would dynamically grow for you. And here's the real change. So if again, we're processing wire 1 right now. If at the XY coordinate in that cell, if we've not seen a wire 1 yet before, we've not been there by traversing wire 1 through the board, then what we do is this is the first time we've seen it, so we timestamp it with our counter, which we initialize to 1. No matter what, we're going to, for each iteration of this, we're going to increment our counter. And then no matter what, also, I'm drawing wire 1, so I'm going to set this to true, that wire 1 is at this XY cell. That greatly simplified what I was doing before. And in fact, when we go to wire 2 here, it's going to be almost virtually identical. In fact, I should, shame on myself, I should have put this into some sort of a function to do it for wire 1 and then wire 2. We started out at the central port. We iterate through. I reset my counter to 1 here, go up, down, left, or right, do some error checking here. And otherwise, it's exactly the same as wire 1. If this is the first time that we've seen it, then we timestamp it with our counter because it's always, presumably, if a wire comes in on itself, then it short circuits, then you don't have to go through that loop. You can always just be there. And then, of course, we set it to true that wire 2 is here. And then we increment our counter. We print the board, but only if it's small. And then what we do is we go through each and every single point on the board. And these are my two conditions, that if wire 1 and wire 2 have both been at this cell, those are the only relevant ones that we care about. This is for part A, and this is for part B. This first part here was the same as before, the one that was successful. We compute the Manhattan distance from the central port and this value, X and J. Remember, X and J are reversed. I and J are reversed. J corresponds to X and I corresponds to Y. But I compute the absolute value here, and if that distance is less than the minimum distance that we found so far, which is initialized to something very large, then we update it. Likewise, now counting the number for counting the part B, where you have to find the minimum number of steps at which they first intersect. Well, first of all, they still intersect. That's my condition up here. I compute the steps by simply looking at those values, the steps here and the steps here. And if that's less than the minimum number of steps I find so far, I just update min steps. At the end here, I report what I've found. I report the expected. I filled those in to make sure that they're correct. And then I free everything up, making sure that I clean up after myself, especially after that last test case, which is going to be rather large. This is the small test case that will actually end up printing stuff. It's as a minimum distance of 6. The 30 here, that's the minimum number of steps, 15 steps for wire 1, 15 steps for wire 2. And then 159, 610, 135, 410. I'm getting the correct answers now. And then here's my actual input. Your input will probably be different. And you can see here that I've already successfully done it. Let me just go ahead and what I do here in the main is then I execute through each one of those those test cases. So I'm going to do them all. All right. Let's go ahead and run it. And as it's still running here because the last one is rather large. There's the initial board, right? There's after drawing the first wire, and you can see that I changed the print function here so that it actually is oriented correctly. It's going right, then up, then left, then down. And then here's the second one. 2 comes in here and goes over here, and 3 and 3. Those are indicating where the intersections are. Of course, this is the intersection for the first part of the problem, the closest one to this original port, and then this one is the closest one with respect to the number of steps that it took to get there. We can see here that I'm passing the first test case, passing the second test case, third, and again, there I've already submitted the answer, but there's my final one. Okay. So again, some takeaway lessons here is, unfortunately, this is kind of a programming kind of competition where they hide all the information from you until you get there. But I was trying to think ahead and trying to think of what I needed to keep track of. I just didn't keep track of enough, and so it led me down the wrong path and led me down to some kludgy code that if I had just taken a step back and restarted and okay, well, this is what I need to keep track of. These are the things that I need to keep track of. So if I knew that up front, then I would have been able to keep track of that stuff. But the takeaway on this is that you can't anticipate everything. That's okay. You can always go back, start again. You can be comfortable with throwing one away. Be comfortable with throwing away your code and starting over fresh from a blank slate, because the very process of going through that going through the exercise, going down the wrong path, that tells you, oh, this is not how I should have done it. It informs you on what the correct design should have been. So throw all that stuff away, start fresh with the correct design. It's kind of like throwing the expression "throwing good money after bad," the sunken cost fallacy, where you really don't want to throw your code away and start over because you've written 100, 300, 400, 5,000 lines of code, whatever you've written. You've written so much code, you put a lot of work into that code, and you don't want to throw it away because you think it has value, but it doesn't have value because it's poorly designed. It's not giving you the answer that you want. It's not maintainable. It's not good code. So be comfortable with throwing that away. Don't throw good money after bad. Don't waste time trying to work with a bad design when you could just throw that design away and start fresh with a correct design. Okay? All right. So there is my solution. I've got now 6 stars. I'm not going to do day 4. I'll do day 4 tomorrow. But again, we're doing this 1 week later because I'm doing this all for a final examination review. And I encourage you to come along with me and do the rest of it over break. Go ahead and finish it out and report back to me if you're able to finish all 25 days. Otherwise, I'll see you tonight in class where we'll do more live coding demonstrations. But I'll be bringing last year's final. Okay. All right. See you then.